Okay, let's take a look at fitting a nonlinear model, a simple one, the species area curve, and compare that with the model that we get treating it as a logarithmic transformation. In my nonlinear models project directory, I'm going to fire up the RStudio. And I'll open up an R script. And I've got some data. Let's see. Nonlinear models, data. There it is. So let's call this species area. And I want to read CSV. Oops. Data. Species area curve. 9 Mile Prairie. 2016. This is data that was collected at 9 Mile Prairie this fall by 3 sections of Natural Resources 222, the Introduction to Ecology Lab. So you have plants, plant species richness as a function of area in square meters. There were, for each lab, there were 4 replicates, actually 3 replicates for the Tuesday lab. And they were either in the old 9 Mile Prairie section, in the new across the fence in the CRP section, or down in the entrance area. All right. Now, this is what we call a wide format data frame, in that there's information that's in the columns that we really want to be able to use. And so we need to do a little reshaping of this. So I'll start by loading up the tidyverse. And I'm going to make this into a long format data set by using the function from tidyr called gather, which is going to gather up those columns and put them into a single column. So the first thing I have to do is say what the data is. The key value is going to have the information that is currently in the column headings, and so that information is rep site. And I think I need to rep site, okay. Call it the key. The value information is going to be species richness. And then, well, let's just see what that gives us. Okay, so it worked. Did it give us what we want? Oh, okay, not quite. So it pulled quadrat area into the same column. So that's not what we wanted. But let's go back here. We can tell it which columns not to include in the gathering process. And that's probably, we could either tell it which ones to include, or in this case, which ones to exclude. So the minus sign here says don't use quadrat area in the gathering process. There we go. So now quadrat area has been repeated one time for each rep site combination, and there's our species richness. That's what we want. Now what we have to do is split rep and site apart, and so we have a function for that too, courtesy of tidyr, called separate. Now I'm using a pipe, so I don't have to provide the data. The column I want to separate is rep site, and I want to separate it into rep and site. It's pretty easy. By default, it's going to split that column on anything that's not a letter or a number. So in that case, it's going to be splitting it on this underscore. So we're going to end up with two variables. So that should work. Oops, there we are. There we have it. Rep and cite. Good. And now we're ready to make a plot. So let's just do this quickly. ggplot. Species long. AES. X is quadrat area. Y is species richness. We want some points. And let's make the color equal to cite. And I want aligned as well. Oh, that's not going to work. Let's just do that. That wouldn't work because we're going to have too many values. So there's quite a bit of variation, but you can see the kind of power curve shape here. So let's fit a model, a nonlinear model, call it species area 1. And the base function for fitting nonlinear models is NLS, for nonlinear least squares. What we have to do is give it a formula, just like we always do, except now the formula, whoops, the y value is SR, is literally going to be the R expression that calculates our power curve. So we have C times quadrat area times, oops, raise the power, Z, and then we have to say where the data is. And then the additional thing we have to do with a nonlinear model is we have to tell it where to start looking for values of C and Z. So I'm going to say start equals, this is going to be a vector, and it's named. C is the species richness when quadrat area is 1. That's down here. And it doesn't have to be exact, but you need to be in the ballpark. So let's say 10 looks like, right? Just about 10. When we're at small areas, it looks like the average is about 10. 10. And Z is a starting value. It's going to measure the rate at which the increase falls off. I'm going to put in 0.2 because species area curves tend to be, well, actually, that's not 0.2. What is it? 0.27 is the, across many meta-analyses, 0.27 is the value that you get for that constant. Okay, so it worked. Let's take a look at what we got. So it tells us what the formula was, and then it tells us the parameter estimates. Z is quite a bit smaller than what I expected. Gives us a residual standard error, which is just the sum of the squared residuals, square root of that sum. How many iterations to convergence, and what the rate of change in the likelihood in this residual standard error was when we got to that particular value. So let's see, what do I want to do? I don't want to take too long here, so let's just fit a different model, except this time we're going to use linear, and I'm going to use log species richness is a function of log quadrat area there we go, and take a quick look at this thing. Okay, notice this residual standard error is quite different. That's not surprising because remember we're on a log scale now. Here are our parameters. The log quadrat area, that's the slope. That is the value of z without having to make any changes. And notice it's actually not the same as the value that we had before. It's a little bit surprising to me that we don't get exactly the same answer, but we don't. And here's this is the logarithm of c, so let's do exp 2.3782, 2.3782 gives us 10.78, which was pretty close to what we got from the nonlinear model, but not exactly the same. So our linear approximation is close, but not exactly the same as the nonlinear model. So there you have it. That's fitting a nonlinear species area curve, both with and without doing the log transformation. You do get slightly different answers. The key is having to set these initial starting values. That's really the new thing that you have to do that we've never done before, as well as write out the expression that we need to use. Species area curve is pretty simple.